Welcome to the Deep Dive, your shortcut to being genuinely well-informed. We take the latest research, tear into the data, and deliver the essential knowledge you need to grasp the bigger picture. Today, we're plunging into something really vital for, well, anyone planning on aging well. How exercise protects the brain. We all kind of know we should move more, right?
Right. It's almost a given.
But we're looking beyond just exercise is good. Our mission today is to unpack a major study that didn't just confirm that, it found something, well, unexpected. A really surprising link between how hard you exercise, your body weight, and mental sharpness. And, it could actually change the advice we give.
Exactly. And we're basing this on solid research. The article is The Association Between Exercise and Cognitive Function in Chinese Middle-Aged and Older Adults. Exploration of Mediating Factors.
Okay.
The authors are Li Gu, Ming Fu, Jian-Jun, Zhi-Wei Huang, and Li Pinghua. It was published in a pretty reputable journal, the Journal of Sports Science and Medicine, volume 24, pages 990-933 in 2025.
Okay, let's unpack this then. What was the core question they were trying to answer? I know past studies have been a bit all over the place on this.
That's exactly it. The findings have been inconsistent. So they wanted to know what specific physiological factors might be acting as middlemen, mediating the link between physical exercise and cognitive decline in middle-aged and older folks.
Right, what's happening under the hood, so to speak.
Precisely. They used data from the China Health and Retirement Longitudinal Study, Charles. It's a prospective cohort study.
So they followed people over time. That's strong.
Very strong for this kind of question. They started with a big group, 3,153 participants, all of whom had normal cognitive function back in 2011 at baseline.
Okay.
Then they checked back in 4 years later, in 2015, to see who had experienced cognitive decline.
And how were they defining decline? Because that term can be fuzzy. Was it just forgetting keys or something more?
Good question. No, it was more significant than that. They defined decline as getting a global cognitive score below 11 points. This score combined tests of episodic memory, remembering events, and what they call mental intactness, basically processing speed and sharpness.
So less than 11 meant a real measurable drop, not just an off day.
Definitely. A clinically relevant reduction in cognitive function.
Got it. Okay, so how do they measure the exercise part? Self-reporting can be tricky.
It can be. They tried to make it robust. They looked at intensity, light, moderate, and vigorous.
How do you define those?
Well, light was things like walking. Moderate was activity making you breathe a bit harder, like, say, bicycling at a normal pace, maybe carrying light loads. Vigorous was the tough stuff. Heavy labor, aerobics, fast cycling, things that really get your heart rate up.
Okay, that makes sense. Relatable examples.
Yes. And they also looked at frequency, of course, how often people did these activities.
Right.
And then to standardize it all, they calculated something called a physical activity score, or PACA. This uses metabolic equivalence METs.
METs, the energy cost.
Exactly. They assigned MW values, like 3.3 for light, 4.0 for moderate, and a jump to 8.0 for vigorous. This gave them a single number for total weekly activity energy expenditure. Much better than just asking, do you exercise?
Definitely more nuanced. Okay, so what was the big picture finding for the whole group?
Well, the headline news is positive. Pretty much any level of exercise intensity or frequency was strongly linked with a lower risk of cognitive decline compared to people who didn't exercise at all.
That's encouraging. But let's get specific. After they adjusted for all the other factors, age, gender, education, lifestyle stuff, how much protection we're talking? Give us the odds ratios, the ORs.
Okay. So remember, an OR below 1.0 means lower risk. For light intensity exercise, the adjusted OR was 0.70.
0.70, so 30% lower risk just from light activity? Wow.
Yeah, not bad at all, but it got better. Moderate intensity exercise showed an even stronger benefit, an adjusted OR of 0.56.
Okay, that's a 44% reduction in risk. Significant jump.
It is. And vigorous intensity was right there, too. Very similar, with an adjusted OR of 0.55, also about a 45% risk reduction.
So going from light to moderate or vigorous almost doubled the protective effect against cognitive decline.
Pretty much, yes. The effort seems to matter.
Was there a specific routine that stood out as the absolute best?
Interestingly, yes. When they looked at combinations, the single regimen showing the strongest protection overall was moderate exercise done 1 to 5 days a week. That hit an adjusted OR of 0.51.
Almost cutting the risk in half.
Yeah.
Just by being moderately active most days of the week.
Exactly. That consistency at a moderate level seemed to be the sweet spot for the whole group.
That's really practical advice.
Oh,
Okay,
yeah.
now, Let's get into the nuances. Did everyone benefit equally? This is where things usually get interesting, right?
Absolutely. And this study was no exception. Let's talk age first. This was a huge factor. The really clear, statistically significant link between exercise and lower cognitive risk. It was mainly seen in participants aged 60 years or older.
Wait, really? So for the under 60s in this study, the effect wasn't as strong or as consistent?
Correct. In the group younger than 60, only a few specific exercise types showed a statistically significant decreased risk, things like vigorous activity 1 to 5 days a week, or being in the second quartile of that PAC score.
Huh. Why would that be? You'd think starting younger is always better.
Well, the authors speculate that maybe in the younger group, other factors are more dominant in protecting cognition. Things like higher education, more complex jobs, what we call cognitive reserve.
Ah, so maybe the exercise benefit is there, but it's kind of masked by that high reserve until later in life.
That's the idea, is like exercise becomes a more critical protective factor once the natural age-related changes really start to kick in, perhaps past 60. Age seemed to moderate the whole relationship.
Okay, that makes a certain kind of sense. What about differences between men and women?
Also quite distinct. For males, the benefit seemed pretty universal. Just about all the exercise types they looked at were associated with a lower risk of cognitive decline.
Simple message for men then. Just move.
Pretty much, but for females, it was more specific. The significant protection was mostly linked to moderate and vigorous intensity exercise, and only at certain frequencies, like moderate exercise 6-7 days a week, or vigorous 1 to 5 days a week, not quite as broad.
Interesting.
And perhaps controversially, the study actually found a stronger overall association between exercise and cognitive function in males compared to females, which, goes against some other research out there.
Okay, so exercise is generally good, but the benefits are clearest after 60 and maybe more universally effective for men than women, where intensity seems more key. Now, pivot time. What was the big surprise? The mediating factor you mentioned.
Right. This is the core insight. The mediating factor wasn't something obvious like blood pressure or cholesterol. It was body mass index, BMI.
BMI, as in body weight relative to height.
Exactly. Changes in body weight seem to be a critical go-between linking exercise to brain health.
Okay, how? Usually we think exercise helps manage weight, and that's good for everything, including the brain.
Well, here's the twist, and it's a big one. For vigorous exercise, regardless of how often, and for the group doing the absolute most exercise, the top quartile, PAC-Q4, the analysis suggested these could actually increase the risk of cognitive decline.
Increase? Yeah.
Through the indirect effect of decreasing BMI.
Hold on. You're saying doing really intense exercise, successfully losing weight as a result. That weight loss itself might somehow harm cognitive function, or at least negate the exercise benefit. That sounds completely backward.
It does sound counterintuitive, doesn't it? But that's what the mediation analysis pointed towards. The vigorous activity itself is likely good for the brain directly, but the consequence, a significant drop in BMI, seemed to counteract that benefit.
Wow. Okay. Was this true for everyone?
Crucially, no. This surprising mediation effect, where lowering BMI seemed problematic for cognition despite high exercise levels, was mainly seen in females.
Mainly in women. Okay, why? Why would losing weight, especially through healthy exercise, potentially be detrimental to cognitive health in older women? This needs explaining. Is this related to that obesity paradox thing?
That's exactly the context the authors bring up. The obesity paradox is this observation, mostly in older adults, where having a BMI that's technically overweight is sometimes linked to better survival and fewer negative health outcomes, including, in some studies, cognitive decline compared to those with normal or low BMI.
Right. So being very thin in older age isn't always the ideal health marker it is when you're younger.
Precisely.
Yeah.
For older adults, a very low BMI can sometimes signal underlying issues like frailty, poor nutrition, or sarcopenia, which is the loss of muscle mass and strength.
Okay, so the theory might be vigorous exercise burns a lot of calories, leads to weight loss. If an older woman isn't, say, getting enough protein or overall nutrition to support that intense activity and maintain muscle, the resulting low BMI might reflect a state of vulnerability that increases cognitive risk.
That's one of the leading hypotheses. The body might be losing too much muscle along with fat or entering a state of lower metabolic reserve. So the intense exercise, while having direct brain benefits, might indirectly reveal or even exacerbate this underlying vulnerability linked to low BMI, especially in women who are often more susceptible to muscle loss with aging.
So the weight loss itself becomes a negative mediator, overriding the positive direct effects of the exercise on the brain.
That's what the data suggests. specifically for vigorous exercise leading to lower BMI in this female cohort.
This completely reframes the conversation for older women, doesn't it? It suggests that aiming for significant weight loss through very intense exercise might not be the best strategy if cognitive health is the primary goal.
It really does. The author suggests that middle-aged and older women should definitely maintain exercise, but they also need to be mindful of maintaining an appropriate weight, not necessarily lowest possible weight.
What does appropriate mean here, though? That's the million-dollar question.
Well, the study doesn't define a specific BMI target, but the implication is avoiding becoming underweight or having rapid weight loss, even if it's through exercise. It's about finding a balance, getting the benefits of movement, without tipping into a potentially vulnerable low BMI state.
That nuance about BMI mediation, especially in women, is probably the most critical insight from this entire deep dive. It challenges standard assumptions.
Agreed. So let's just quickly summarize the main takeaways. 1, more intense and frequent exercise generally links to better cognitive function, especially moderate activity.
Right, that near 50% risk reduction.
2, this benefit is much clearer and more significant in adults aged 60 and over.
Age is key.
And 3, exercise likely impacts cognition partly by changing BMI, but, and this is the crucial part, a reduction in BMI resulting from vigorous exercise might actually increase cognitive risk, particularly in women. That's the paradox.
Okay, now we always need to mention limitations for scientific balance.
Of course. This was a prospective study, which is good, but it's observational. It shows associations, strong ones, but can't definitively prove cause and effect like a randomized controlled trial could.
Right, correlation isn't causation.
Exactly. And although they used good methods, the exercise data was still self-reported. People might not always remember accurately. That's recall bias.
Understandable limitations. But the findings, especially around BMI, are still pretty compelling given the large sample and longitudinal design.
Agreed.
So this leaves us with a really provocative thought, doesn't it? If the obesity paradox holds true for cognitive health and aging, what does appropriate weight really mean? How might that differ from the advice we usually get, which is often focused on cardiovascular health, where lower weight is typically better?
That's the big question we need more research on, finding that sweet spot for cognitive aging versus other health goals.
Definitely something for you, the listener, to think about. The authors strongly recommend more research into these mechanisms. If you want to read the full study yourself, and it's quite detailed again, the title is The Association Between Exercise and Cognitive Function in Chinese Middle-Aged and Older Adults. Exploration of Mediating Factors by Li Yu and colleagues in the Journal of Sports Science and Medicine. Thank you for joining us for this deep dive. If you found this valuable and want to stay ahead of the curve on research like this, make sure you follow our channel and turn on those notifications. We'll